What we'll do is we'll start from the basic scratch on how this is done, what all things would we be discussing in the course, what all components would be there, what is the teaching style. I'll discuss a sample project. I'll show a mini project that has been done by the students. It's not a major project, it's a mini project that you'll be doing on a weekly basis, and so on. So basically, this is a in kind of an informal session wherein I can explain what we normally cover, what is there for you all to learn and practice, and wherein you all can ask questions and get your queries resolved, or if you have any specific question regarding any specific topic and so on. Right? So basically, the process of data science is a step-by-step process. The steps, what we actually try to achieve is we are trying to use data science, we are trying to use mathematics and some computer programming to solve some business problems based on data, right? And the solution should give me something, some pattern, some information, some knowledge for that particular business, which is not obvious. Something which is not obvious, we cannot find out by simply looking at the data. So those kind of information can be extracted using data science. Where do we use this kind of logics or algorithms or whatever we can call is in cases where we have lots of data and we need to solve basic business problems. Let's say there is a dip in sales, or maybe you need to launch a product. In which region do you launch that product, or which sector of customers are the best customers to sell your product, or how to maximize your profit or minimize your loss, or maybe predict future prices, predict the future trend of the market or of the product. So anything that maps to the business processes and cannot be solved using general tools or general analysis of data comes into the data science part. So what does data science do? Means what special thing does the data science add in place of the legacy technologies that we have? So to understand that, we'll just go through the entire cycle of a data science project. So the project starts at the point when you receive a problem statement. Let's say you have a problem. Let me think of a sample problem. So let's say there's a company which sells shampoos and they want to launch a new kind of a shampoo. So there's a premium segment of shampoos that needs to be launched. Normally, if 100 ml bottle of that shampoo costs 100 ml bottle of a normal shampoo, if let's say it costs 100 rupees, the new one would be costing 300. So it's a premium segment, something which is costlier than the normal segments. And they want to know where to launch or where to open my store so that these kinds of products can be sold in quantity. So that's a business problem. So you need to launch a product and you need to decide, okay, let's launch a product in, let's say in Chennai. So in which areas of Chennai should I open a outlet? Right? So this is a sample problem. How to solve this problem? So according to our data science cycle, what happens is, so let me, so the process starts at this point. So this is the point wherein the actual problem statement comes to you. So you get information that the company is launching a new product line. They want to know which areas or which places or which groups of customers are most likely to buy this product, so that their cost in marketing would be reduced, the profits can be enhanced, and all those things. there's always profit involved in a data science project. So what would be your first step as a data scientist? Or some of the steps, I guess, are used in ETL, but we'll cover the entire flow. The first step is the data acquisition step, right? So data can be available anywhere. It can be in an Excel format. It can be in a company databases. So every company has a set of database wherein they store the customer data or all those kinds of data. Or it can be in another database through an API. You can pull the data. So there can be various sources of data that you might have to interact with. Right? The first step is how to get data into our environment. You need to solve a data science problem. First thing that you need is data itself. And the data can be from multiple sources, multiple storage systems and all those things. So if there is a problem of forecasting, real-time forecasting of stock prices, then you need real-time stock data. That can be fetched from online repositories or APIs, some real-time APIs that would give you the data. So all these things, so you need to understand how to get data from different sources to our own system, to our own environment. Once we have got the data, we go to the second step, which is actually ETL. Correct me if I'm wrong. Okay, so in the second step, data preparation, it's also called data cleaning, wherein we focus on cleaning the data. Normally what happens is every real-time or real-world data is noisy. You understand? Means everyone knows. Excuse the noise here. Okay, so noisy means there is some error, there is some added quantities, there is some subtracted. So data is not pure. It has some bias. So our step in the data cleaning process would be to remove the noise from the data or to check whether some of the rows have missing values or some of the columns have values which cannot be there, outliers and all those things. So basically checking the data for any anomalies, something which is inconsistent, there's some spelling mistakes, one of the zeros is more, so let's say the amount is somewhere amount is mentioned and instead of 10,000 someone who is writing the data has written 1 lakh. So that if that is not caught or that particular data point is not removed, it would create problems in the future steps. So how to detect that there are missing values or these kind of values are wrong values. So we will be learning all those steps. And once the cleaning part is done, the data is transformed into uniform scale. Why uniform scale? So let's say you are dealing with a data set which shows you the price of house and the area of a house. So even though area is in terms of square meters, it can be 30, 40, 100, but the price can be in lakhs or crores, right? The range is very different. Something is in hundreds and something is in crores. So normally what happens is this kind of high range difference is not, means the difference between the columns is not preferred. So what we'll do is we transform everything into a single scale from 0 to 1 or 0 to 100, whatever is the requirement. And then we proceed further. Right, so
No.
okay. So once we get the data and we clean it, and by cleaning I mean you remove the errors from the data. So let's say there's a date column, and normally the data has third, means the date is in format 3rd July 1995, 4th July 1997. So this is the format. Day or means the day, then month in 3-letter format, May, June, July, Jan, Feb, and complete year in 4-letter format. And if there is an anomaly in between, someone writes instead of 3rd June 1997, he writes June 3rd, 1997. So there are fixed rules in Python or in any language that you are using that can automatically extract dates. But if there is a change in format, that will give you an error. And if the data is around, let's say there are 50,000 rows in that particular Excel. So you need to determine whether there are anomalies like this which need to be removed or rectified. So all those things are taken care in the data preparation step. The next step is analysis. So most of the data analysts in today's world, so you have heard of data analyst, business analyst, or business intelligence guys, they stop at this step. Why this step? Because once the data is cleaned and errors are rectified or removed, next step is plotting the entire thing to understand the trend or behavior of the data itself. So plotting would give you some details about the nature of the business or might be the problems, underlying problems that are there. So basically analyzing the data in form of graphs. I'll show you some steps after this. So half of the information that data science project gives comes from the analysis stage. You need to analyze the data itself, how is it behaving, what is the problem, how can it be solved, and all those things. So in a nutshell, if there is a problem and someone comes to you for a solution, data analyst actually figures out where exactly is the problem coming, what is the root cause of the problem. The next step which data scientist adds is how to solve that problem. So getting data, cleaning the data, analyzing it to get the root cause of the problem, and the last step is using some mathematical tools to actually get a solution for that problem, right? So in data science, we broadly divide everything into three classes. It's either classification problem, or a clustering problem, or a prediction or forecasting problem. So either you need to forecast something, or you need to classify something, or you need to cluster something. Right? So the example I gave in the beginning, you have a population, you need to understand which area of the population should I open my outlet so that my product sells a lot. Right? So you have multiple areas. You need to classify every area as good or bad. If it's good, you can open a dealership or a shop there and start selling your new product. So that's a classification problem, right? Prediction problem is you need to predict future data, future amount of sales or future cost of something, of a house or a product or anything. Predicting stock prices, all those things comes into the prediction part. Clustering is you have some data which you don't know, means you have a general data. You need to make classes. So for that we use clustering. So individually how it is done, what are the differences, what all technologies do we use. So we'll be discussing all these later. So once you use mathematical tools to solve the problem, maybe classify, give us a classification solution, then it is tested on real world data and then it's deployed. So this is the entire flow of end-to-end flow of a data science project. Right? So some of the areas where this is being used. So I'm assuming you have heard of data science, some data science application in marketing. Have you? So the one I just told, where to sell or where to set up advertisement for a new product is an example of data science in marketing. So you need to classify areas which are most relevant for your product, and you use banners, posters, advertisements in that area so that people get to know about the product more. In social media, you have suggested friends, suggested groups, all those things are basically data science. Healthcare, so almost in all of the spheres, we get to have a data science project, right? So at any point, if you have any questions, please do ask.
Hi Siddharth. So the role, Amit here. So role of the data science will be all from the gathering the collection of data till the communication and prediction.
Yeah, collection of data, reprocessing, and then based on that modeling. So prediction, forecasting, all those things. So in credit, you go to a credit card company, they'll use data science to predict whether you are a good customer or not, classify you as a good customer or not. So that classification is being done using data science, right? So these are some of the big companies that use data science as a
Yeah.
tool. This is an older chart. Right now, almost all the companies are using some form or the other of data science for their business optimization, reduce cost, increase profits, and all those things. So these are the bigger ones, bigger players. And so what we'll be learning through this course? First of all, we'll be using Python as a tool of development. So we'll be starting with Python itself. We'll be learning Python to a level that we can use it to develop some basic codes, software, and all those things. Because Python would be our main tool for data science. Once we learn Python, we'll be moving to data science concepts, basics of data science, how these things are done, some mathematical concepts, some Python-based packages that are most used, how to visualize data, how to visualize in a very beautiful format, uh, concepts of machine learning, which is supervised, unsupervised, all those things. So basically, end to end, we'll start with Python basics, then Python programming, hands-on programming, then basics of data science, some theoretical concepts on mathematics, and basically what's happening on the algorithm side that we'll be using. Then using some hands-on packages to develop our own models, testing. Then we'll be finishing it off with best practices and how do corporate companies develop products in data science and all those things. Okay. So I'll just quickly go into a use case. So this is a Titanic problem wherein.
Yes.
So, okay. So I was speaking about a problem wherein we involve the data set of Titanic. So let's say, as a data scientist, someone comes to you and says, we have the data of all the passengers of Titanic. You need to take the data, and if something, God forbid, if something happens tomorrow like this, can you predict, given a passenger, can you predict whether that passenger would survive or not? Right? So you're getting the problem. So we have a historical data of all the passengers who were traveling in Titanic. If something of that sort happens in the coming future, can we use that data to understand whether a particular person would be surviving or would not be surviving? So we will.
Their risk analysis or something.
So this would come under risk analytics. Not just Titanic. So this is just an example, but similar
Okay.
use cases we have. Let's say we have a data of bank frauds that has been done in last 30 years.
Okay.
Now using that data, if I ask you to make a model that would given a transaction that would term the transaction as a normal transaction or a fraudulent transaction, right? Similar
Okay.
data, it's a similar approach like the one we are
Okay.
using here, but
Okay.
here we are classifying it as survived or not survived. So for data science, it's just binary classification. It's just there are two classes, yes or no. You need to classify yes or no. So in this case, the
Okay.
yes means survived and no means didn't survive. In the bank's
Okay.
case, it
Got it.
yes, yeah. So in the bank's case, yes means it's a normal transaction, no means it's a fraudulent transaction. The kind of
Mm.
data changes, but the algorithm and sorry for that, algorithm and the methods remain same. So as an
Okay,
example, so
sir.
this is one of the most yeah. So this is one of the most famous machine learning starters example. So people who try to enter machine learning enter with this data set. So it's a very comprehensive, detailed data, which is one of the ideal ones to learn what's happening in data science. So that's why we're taking the example of this. But based on this concept, we'll be using it for risk prediction and credit card data, um, sentiment analysis of text data. So basically, given us text, or maybe you work in a company which has an app in App Store, let's say Ola, right? And lots of people actually provide reviews on the App Store itself, right? So your purpose is to take all the reviews and classify it as a negative review or a positive review, or maybe a neutral review. So you have three classes. So using the same methodology, same algorithms, you could classify text into three categories. So we'll be extending this model to work on text data, how to do some modifications so that we can get a good accuracy, all those things. But the base remains same, the one we use here, right? So,
Yeah.
so I'll just show some snippets on how Python looks. So if you see, the first line is basically something which pulls a data from a CSV file. CSV is similar to Excel, it stands for comma separated values. So basically it's using an import function to import a file. So as you can see, Python itself is not difficult. It's pretty easy to learn and start developing on Python. Dot head basically means to print the top 5 rows of a data set. So if you can see the data, it's a descriptive data. It has name of passengers, and the class means is it the passenger was the ticket was a first class ticket or a second class or a third class, gender of that passenger, age, cost of the ticket, and all those things. So if you notice, there's a column named survived, right? Survived has only two numbers, either 0 or 1. 0 means no and 1 means yes. So basically, this is the main column that we need to predict in the coming parts. But right now it's given so that we can understand, we can train a model based on that. So we do some analysis, data. So it's a big project. For the demo purposes, I'm skimming it to just 3 slides. But this is the visualization step. So we can see the gender wise, there's a gender bias. Males, the probability of survival of males is lesser than the probability of females. Again, if the female is of first class, then the survival probability is highest as compared to third class. Then based on age, you can see this histogram kind of a Gaussian distribution wherein you can determine where is the most number of people survival rates. So you can determine what is the average rate, what kind of disbursement is there, and all those things. So we'll be using parts of statistics, parts of mathematics, linear algebra, but nothing to worry. Basically, we'll not be using a copy to calculate all those things. right? Okay. So once everything is done, there's a model called random forest that we have used here for predicting whether a given customer would survive or not survive. So there's a lot of things how random forest is developed. It's an advanced form of a decision tree, which is basically a rule-based kind of a thing wherein you have nodes and all those things. So we can expand on that once we go into detail. But basically, yes. So we'll be starting with very simple examples like this Titanic and how to scale up these problems into more severe domains like risk analysis or sentiment analysis, multi-class classification, and all those things using the concepts that we have discussed in simpler problems like this, right? So I would have shown you another example, but my laptop has it's not working as it should be. But basically, what we have done is there's a mini project that is going on right now in our batch, which is a recommendation system. So you guys have heard of recommendation systems? Anyone?
No,
No
Siddharth.
one? Okay. So basically, you look for a movie in Google. Let's say you search Interstellar, right? So along with Interstellar, what Google does is, yeah, maybe you are using Amazon Prime or Netflix or YouTube. In YouTube also, you have videos which YouTube suggests you, recommended videos or YouTube recommendations. So recommendation system is a data science model that would recommend you products based on your based on your behavior, watching patterns. So if it's a video streaming site like YouTube, it would check what kind of videos you see, what kind of videos are being watched by people of your age group in your area in India, and all those things. Take all those information, create a model, and would predict or recommend you videos. If it's not a video domain, if it's a marketing or sales domain, like in Amazon, you have recommended products. Amazon, Flipkart do recommend products to you, similar products like this. So these things are part of the recommendation system. Basically, using the data plus the data of people around you in your age group, in your country, in your domain, in your gender, or time commercial applications. So recommendation system is one of the most commercial application that is being done right now in data science domain, right? Product recommendation, movie and video content recommendation, basically app recommendation, and all those things. Okay, so this is what I have right now here, but basically this session is meant to answer your queries and doubts. So if you have any, you can just go ahead and ask.
Um, Hello, Siddharth. I have a question like the model. So modeling is
Mhm.
like a tool, or we are using Python only for prediction. The all the rules and packages.
So we are using Python itself. Everything is done in Python from scratch. And modeling, as in, it's a combination of tools and algorithms. So let's say it's the one I'm talking about, recommendation systems. So how to create a model, how to use data and go into the recommendation part, how to fetch, what kind of logic should be applied, uh, how to match one movie with another. All those things come under modeling itself, and
Okay.
all those things are separately done in Python. So
Okay. So visualization, cleaning data, everything will be done in Python itself. The get data, visualization, modeling.
Yeah,
Everything done in Python only. Sure.
yeah. Everything we'll be doing in Python. So even fetching of data from a database, we'll be learning how to connect with databases and fetch data, cleaning of data, visualization, everything would be done in Python.
Okay. So what will be the actual role of data scientist? Like I can see it's divided into the getting data, cleaning data. I mean, actually, I am as an ETL developer. I'm working on getting data, cleaning data, and transformation. Till that only. So
Yeah,
as a
yeah,
data scientist, also need to learn visualization data like analytics tools and
yeah. So
also the mathematics.
yeah, in addition to what you do currently, you will be learning how to analyze data using existing tools. Means checking what is the trend of the data, how is it behaving, what is the seasonality. So if it's a time series kind of a data, what is the seasonality, stationarity, all those things. And then you'll be learning on how to model. So there are multiple mathematical models. So if you need to predict something in future, it's normally
Okay.
for time series, anything is there for prediction. So what kind of model? So what is auto-regressive modeling? How to calculate moving average? There is a model called means combining these two becomes ARMA, auto-regressive moving average prediction. How to use that model to predict. So
So
any more
is it
questions?
the theory and the real practical, like how it will working in the organization practical way? Currently, like I'm collecting data, I'm loading data, transferring, but I have no idea what kind of data I'm loading, what is the use of
So
purpose of that. So,
yeah, so we'll be discussing all those things. Data we'll be getting. There's a site called Kaggle which has real data that is provided by companies as part of competitions. So we'll be using real data sources that is there in Kaggle, and based on that, we'll be discussing everything and what kind of data to use, how to manipulate, how to extract all those things.
okay. I wanted to ask, like how organization is looking at the data scientist and how it will affect. Like I'm working as a ETL developer for 5.5 years now, and if I want to transit my career to the data scientist, so how the like I'm working in financial sector, like banking sector.
Mm-hmm.
So how like organization will expect from me as a if I complete 6 years. So it will
Mm-hmm.
as a data scientist or data science field, I will be a junior only. So how it will be, I'm going to be treated in there, like the
So
salary or the, even the
yeah,
expectation.
so it would be a new role, and salaries normally it's not because you have a experience in data sector already, so your salary also would be changed. So
Okay.
the role would be changed. You are right now develop means working as an ATL developer. The role would be changed on risk analysis or risk analyst or basically the risk analysis sector. In banking, normally data science is used for loan dispersal and risk analysis segment. So you will be transformed into the risk analysis sector, so that you can analyze the risk of loans or check the validity of documents or check if there is a fraudulent transaction, fraud checking, all those things.
Oh, okay. Also, is it possible to transform to customer base, like customer services, like Amazon or there is a
Yeah,
travel agency?
definitely, yes.
Uh,
So as I said, that even though domains can be different, but the technology or algorithms that we use are almost common. So data science, wherever, so data scientist doesn't have a relation with what kind of domain he's working in. If it's a financial domain, he actually is doing classification. He given a good data, he can classify anything. It can be a good or bad transaction, or good or bad customer, or good or bad product, anything based on domain. So you actually
Okay.
become domain free.
Yeah, but